coordinate plane using the origin 0, 0 as the center of dilation and a scale factor of 2 to form the triangle A prime, B prime, C prime. Okay, so here we go. So the center of dilation is 0, 0 right here. Okay, so that stays the main focus. Scale factor of 2, that means they want it 2 times larger. So we just multiply all the coordinates by 2, times both of these by 2, so A prime would be 6, 14. B prime would be multiplied by 2 would be 14. (14/6). C prime is times 2 would be 6, 6. So 6, 6 right here. And then force, that's C prime, 4, 14/6 right here is B prime, and then A prime is 6, 14, which is right there. Okay, connect them like that. And then you draw those dotted lines for this linear. If you have a ruler, make dotted lines all the way like this to A. And then all the C's, all the C's together. And all the B's together from the center of dilation. This is an enlargement because it started out with small and it got larger. Okay? Common sense, right? It's greater than 1. Okay, 2, 5. That's A. 7, 2. And 2, 2. Let me connect these. On the grid, and this says dilate triangle ABC on the grid using point C as the center of dilation. That means the point C's do not move. Okay? What are the coordinates of A prime, B prime? Okay, by scale factor of 2. This is 1 whole, 2. A prime, 1 whole, 2 wholes, B prime. Like that. That's it. You got your 2 triangles, the black one and the red one. What are the coordinates for A prime? A prime is 2, 8, and B prime is 12, 2. Okay. 3A, we want to make it half as big. And the center of dilation is here. So half means divide by 2. Factor scale, you multiply half. Factor scale of a half is divide by 2. If it's It's whole numbers you multiply, fractions you divide. Okay, so a prime is 1/7. Divide by 2. B prime is 7/3. C prime is 3/3. Divide by 2. Okay? So your coordinate A prime is 1/7. B prime is 7/3. C prime is 3/3. That shape should be half the size as the big one. This is called reduction. It's less than 1. 1 is the original. And because it's less than that, it's a reduction. So this is called reduction. And then you take a ruler and go from A all the way to the point center of dilation. Take the C's, center of dilation. Take the B's to center of dilation. Okay, and you got that. Here, sorry. X, Y, Z, let's graph that. X is 217. 17, 17. Sure I graph right. Count right. X, Y, and then Z. 17, 8. Okay. You count these. So there are from 2 to 17, so most likely 15. Just to make sure, 5, 10, 15. Yep, 2 minus 17 is 15. So it's 15. And 8 minus 17 is 9. Count to make sure that I graph 9. Yep, 9. That's 9. Oops. Okay. Reduce triangle XYZ on the coordinate plane using the Y on the center as the center of dilation and the scale factor of 1/3. Okay, Y is your center of dilation and the scale factor of 1/3. So reduce this to 1/3. That means this stays put. Okay, this point Y stay put. Reduce it to 1/3. Where would it be a third? A third would be right here. A third of 15 is a third of 15 is 5. Divide 15 by 3 is 5. Right there. So that is now your X prime. Okay? And a third of 9 is 3. So right here, 3 away from the center of dilation is right there. That becomes your Z prime. Okay, I'm going to erase this 9. And, oops. I got my red triangle and my purple triangle, the big one and the small one. Okay, X prime is what? X prime is, we know it's going to be 18. But X is 11. Z prime is 6, 17, and 14. Okay. Reflections. Describe the transformation. This is transferring from here to here, laying down, then standing up. That's a rotation. Okay, 12 o'clock like this. So it goes this way. So that's counter, right guys? Yes, that's counterclockwise. So it's 90 degrees counterclockwise. Okay, let's see the rule. Let's look at the rule. The rules, you only need 1 point, okay? Rules, you need 1 point to identify. Let's do Z. No, you guys mess up with zeros all the time. So I'll do J. J is -5 and -2. And J prime is 2, -5. Okay, so from its original, which is XY, what changes? Definitely the switch in them. So Y became X and X became Y. Now here's the difference. This was a negative, this turned to a positive. So the Y became its opposite right there. Okay? Let's look at this one. Definitely not a reflection, because I can't cut this in the middle like this. And if it is, and it's not directly across from each other, that's a reflection, so that's not a reflection, okay? And it's not a rotation because it stayed standing. So we eliminate reflection, rotation. They only want a translation. Okay, this is a translation. You rule out them, okay? Translation. Going left or right. Okay, it went right 4 before it went down 1. Going right. Oh, don't use the word going. Sliding. Translating. Sliding right 4 and down 1. Okay? You don't have to use horizontal or vertical. If you want to use horizontal, you would say translation sliding 4 horizontal and -1 vertical. Okay, so we'll use our F. F is at 5, 4. Negative. If you get your positive and negative wrong, you'll get your rules wrong. F prime is at -1, 3. Okay, so your rule is, here's your X, here's your Y. XY leading to, what's happening to the X? Let's see. To get -1, you have to add 4. Using this number 4, you have to add 4 to get -1. So X add 4. And then the Y's. See what's happening to the Y's. To get 3, you have to -1 to get 3. So Y -1. Okay? Makes sense because right is add, down is minus. Okay? Alright, let's do this. This is definitely not a rotation because it stayed looking the same way. It didn't rotate. Laying down, it didn't stand up. So we eliminate that. Is it a sliding? No, because this went 2 and this went a lot more than 2, so it's not sliding, so it has to be a reflection, but you need to find where it cuts in half. So to find where it cuts in half, because you guys are having a hard time with this, because sometimes I can give you a reflection over 1. Take 1 point, and where it's half at is at x. You see that? And if you take f, these 2 points where it's cut the same distance as this way and this way is right here over x. So this is a reflection over the x-axis. Okay? Alright, and what are my rules? Let's choose a point. Zeros is harder to see, so don't choose that. We'll do f. F is -1, 3. Here's 0 line. And then f prime becomes -1, -3. So as you can see, the x stayed the same. So here's our rule. X comma y changes to our rule. X stayed the same. Y just becomes 3 and becomes its opposite, -3. So y became its opposite. Okay, here, well, let's try reflection. Not a reflection because that would be here, here, and here. So it's not a reflection. Okay, let's try reflection, translation. Okay, down. Nope, this went down and over, so it has to be the same each time. So it's not translation, so it has to be a rotation. Okay, rotation would be on the opposite side. That would be 180 degrees, because 90 would be here or here. Clockwise here, counter here. Right? Yes, right. So it's all the way more than that. That's a rotation of 180 degrees. Okay, with 180 degrees, it doesn't matter if you say clockwise or counterclockwise because you end up with the same. So you just say rotation of 180 degrees. Pick 2 points. B here. So it's B. No, let's not choose the zeros. It's harder to see. Choose this here. That is -4. Choose x. 2 and x prime. Okay. X prime is 4 and -2. Okay, making sure I'm right. Your rule is x comma y. This is your x and this is your y. What did they become? They stayed in the same spot, just it became its opposite. So xy stayed in the same spot and just its opposite. Put a negative. Negative means its opposite. Uh-oh. My reflector isn't working. Guys, are you on the internet? Okay, my thing is slow. Anyways. I'll stop and record this and finish the rest because things are going slow. I don't know why. Oops. And you know what? I just finish this because it's a pain in the butt to redo. Okay, justify if it's state if the 2 triangles are congruent, and then if they are, if it's side by side, 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 angle, side, angle, side, angle, or angle, angle, side. Justify your reasoning. Okay, so we're doing three things. Are they congruent? Side, side, and this is the other side. Yes, they are congruent by side. So triangle, triangle, N, I have this, triangle, N, P, M is congruent to, that's state if the two triangles are congruent, so we're stating it, they are. Triangle, N, P, O. Make sure they're in the same order. If not, I'm taking a point off. Okay? Now, your test is this Thursday. These will be on there. And I'm not going to do a lot of reviews because I'm running out of time. The reviews are the ones from the worksheet that I've put in. So if you're not doing them, you're not understanding them, you need to look at your other notes or homework to help you out. So I'm not going to do the review worksheets for test like I did. Okay? So we're going to just finish and take a test. Maybe the day before review, but it's not going to be over everything. Can't do that anymore. We're running out of time. And the final will be the same way. Won't be reviewing over everything. Just have to review as our lesson goes and do them. Okay. State if the congruent by, these two triangles are congruent by side, side, side. Okay? And you need to write the side. NP, line segment NP is congruent to line segment NP. Line segment NO is congruent to line segment NM. And line segment MP is congruent to line segment OP. Okay? The next one. Okay, this is angle. I see an angle. I can't go this way because there's nothing. Angle, this has to be side. And it's empty, can't go that way. This is another angle. And there's nothing here either. And so we can't go that way. And this is side. So if this one, let's see. Angle, angle, side also. So triangle BAC is congruent to triangle EDC by angle, angle. I'm sorry, this was angle. Write S instead. Side. Okay, so we go AC is congruent to, we're justifying it now, DC side, line segment CA is congruent to line segment CE, which is congruent, and line segment AB is congruent to line segment DE. Okay, this one here, these are congruent. So this is angle, nothing here, we can't go there, and nothing here and here, we can't go there. So this is not congruent because there's not enough information. Not congruent because you can't have empty here and here, both. Okay, and only have one here. And the same way on the other side. Congruent, not congruent, not enough. ENOUGH, information. Information. We cannot put anything there. We know these are congruent though because it's shared. Okay? And now one of those hard ones that I said will be on the test, like you had on a multiple choice, where you have to split them into two to see it. So you guys, when you can't see it, you need to split. Okay, with side angle, you can't go on this side because there's no angle and there's no side. It can't be completed. Too many incompleteness. You have to go this way. Side, angle, and then side. Okay? Same thing here. Side, angle, and then this side. So we know that triangle MNO is congruent to QRO. You need to keep it in the same order. You went from here, here, there, so you need to go this way. The corresponding angles needs to correspond in your letter. Alright, so by side, angle, side. Justify MN line segment is congruent to QR line segment. NO line segment is congruent to PO. Okay. And oh, we forgot the angle. Sorry. Can't write it like this. You cannot put the side. You need to write angle next. Angle N is congruent to angle P, and then NO line segment is congruent to PO. Okay, and then we're done. I believe that's it, right? I gave you 3 pages of review.